Right now, your phone is suggesting songs you might like, shopping sites are recommending your next purchase, and your navigation app continuously predicts the fastest route to your destination. These actions are powered by algorithms. An algorithm is simply a set of mathematical rules or instructions given to a computer to help it solve a problem or make a decision. To understand how these systems are learning about you, make sure to hit the subscribe button and check the link in the description or pinned comment below to dive deeper into today's topic. For decades, computing relied on a strict bottleneck, the human programmer. Software required engineers to type out every single instruction manually. If a rule was not explicitly written into the code, the computer simply could not perform the task. As the internet expanded, we began generating massive amounts of digital information. Writing rigid rules for every possible scenario within these huge datasets became impossibly slow and entirely inefficient. The old method hit a wall. The solution was machine learning. Engineers stopped hard-coding rigid step-by-step instructions. Instead, systems ingest raw data, finding the patterns on their own. Look at this nested structure. Artificial intelligence is the broad goal of reasoning and problem-solving. Machine learning is the specific engine inside that boundary, achieving intelligence by learning directly from data. By removing the human programmer from the middle of the process, computers stopped acting as mere calculators. They became systems that improve their performance over time, without continuous human intervention. The mechanical advantage of these systems is their ability to process massive datasets at speeds no human brain could ever match. This processing speed drives widespread automation. Organizations are handing over highly repetitive tasks, such as scheduling, report generation, and manual data entry, to software, which frees up human employees to focus on creative and strategic work. When historical records are fed into these models, they generate data-driven decisions. This animated graph shows how raw, chaotic information is sorted to accurately predict market trends or instantly flag the irregular transactions that indicate financial fraud. Humans make mistakes, especially when executing complex calculations over long periods. As the model isolates an anomaly down to a single data point, it demonstrates a level of mechanical accuracy that significantly reduces fatal errors in high-stakes environments. That precise tracking is what builds hyper-personalization. By mapping out a unique pathway based on your individual historical data, these systems power adaptive learning platforms in education and curate the exact media recommendations you see on streaming services. By reducing manual labor and identifying patterns at this scale, AI systems significantly boost industrial productivity. Because of these efficiency gains, economists project that the widespread adoption of AI could add trillions of dollars to the global economy in the coming decades. These algorithms are no longer confined to digital screens. They are actively operating the physical infrastructure around us. In hospitals, machine learning models analyze complex medical images, assisting doctors in detecting early signs of disease with precision comparable to top medical experts. Inside banks, the software continuously runs real-time risk assessments and executes algorithmic trading. Algorithmic trading is the use of automated computer programs to buy and sell stocks at speeds and volumes impossible for human traders. Across the manufacturing sector, smart factories deploy these systems to monitor their own equipment. They use predictive maintenance to identify physical wear and tear, fixing machines before they actually break down and halt production. Out on the roads, self-driving cars rely on these models to analyze their physical surroundings. The vehicles continuously map road conditions, detect pedestrians, and track obstacles in real time to navigate safely and prevent collisions. The transition is clear. Digital pattern recognition is now performing the heavy lifting of physical labor, from diagnosing illness to navigating our highways. Looking to the near future, these models will scale up to manage the energy consumption and traffic flow of entire smart cities, while analyzing global climate data to monitor deforestation and protect vulnerable ecosystems. But this rapid scaling brings serious complications. Society is now grappling with strict data privacy concerns, the risk of human bias being coded into the algorithms, and the very real threat of job displacement due to automation. When it comes to the workforce, the reality is specific. The software itself will not replace humans. However, professionals who know how to leverage these tools will replace those who do not. This transition is creating massive, growing demand for new roles like data scientists, AI engineers, and NLP specialists. NLP stands for Natural Language Processing, a branch of computer science that helps machines understand, interpret, and respond to human text and speech. If you want to position yourself for these roles, you can explore professional training and certification programs right now. Check the link in the description or pinned comment to visit pcds.in and start building industry-ready skills. And make sure to subscribe to this channel for more deep dives into the technologies shaping our world. The machines of the 21st century are built to learn and adapt from the data we provide. The future they create belongs to the people who choose to learn, adapt, and innovate alongside them.